This is Higher Maths. We're looking at the straight line topic and we're looking at the distance formula. Now the distance formula is a method to work out the length of a straight line between 2 points. We don't need to see it in a diagram, we may just be given the 2 points as coordinates. And the distance formula is just basically Pythagoras Theorem, just written in a different way. Right, let's go ahead and we'll try the first example that's here and we'll see how we go about working out the answer to this. So I want to know what the length of this line is here. Now what I've done is I've drawn up a right angled triangle that will help us to understand how we go about this work here. Right, so I'm going to label up the points. I'm going to label this one x1 and this one here y1. Up here at B, I'm going to label that x2 and y2 there. Okay, so if I was doing this by Pythagoras Theorem, simply what I would do is I'd be working out the length of this line here, and this line here would just be the y2 minus y1. It would just be the distance between B and A from a vertical point of view. So y2 minus y1 would really be 6 minus 2, which would give me a distance of 4 on that side there. On this side here, I'd be looking at the x coordinates, so I just need to look at the x coordinate of B. So this will just be x2 minus x1, and I'll just put in the coordinates there and we'll be able to work out the length of this line here. So in this triangle, this side here will be 3, this side here will be 4, and what I have to do is by Pythagoras I would work out the length of AB. Now when I've just got the coordinates, I can go straight into the distance formula and work that out. So what I'll go for first of all is I'll go for the length of AB is going to be equal to, and all I'll do is just set up the distance formula here. So it's going to be x2 minus x1. What we're going to do is we're going to square that. We're going to add on to that y2 minus y1, and that will be squared. Let's substitute the coordinates in, and all we're going to do is work through the working from the information we put into this formula. Right, x2 minus x1. So x2 would be 4 take away 1, okay? So that's x2 minus x1, and that's going to be squared. Next what I'm going to do is I'm going to look at y2. y2 is 6, and y1 is 2. And that's going to be squared. Now all I'm really doing in amongst this distance formula is the work that I was doing here to work out the vertical and horizontal sides of that triangle. Right, so what I've got here is 4 take away 1 will give me 3 squared. 6 take away 2 is going to give me 4 squared. Now when I square that out, what I've got here is I've got 9 and I've got plus 16. Gathering together, root 25. So basically the length of the line AB is going to be 5 units. Okay, 5 units long. And that there is just the practical method of using the distance formula to work out the length of a straight line. Now why don't you try this question here and this one here? Okay, I'll give you the answer in 1 minute. If you freeze the video, you can try the questions. The answer for this one here, the length of CD is going to be equal to 10. The length of E to F is going to be in surd form, and I'm going to simplify it down to 5 root 2. So that's going to be the length of EF, and that's the 2 questions there. Just follow the same method as I've used in example number 1 here for these 2 here. Just watch out for some of the negative signs, the way that they work through. Okay, just taking things a little bit further, what I'm going to do is I'm going to show you maybe some more complex questions that you may receive on this simple formula that's here. What we may have to do at times is work out the value of some missing coordinates using the distance formula. So let's do example number 1 and I'll leave the other 2 examples for you to try. Right, so what we have here is find the value of k when the length of a line is 5 units and coordinates of A are 9 minus 4 and B would be k in the x coordinate there minus 8. Right, so what we'll do is we'll just substitute the values that we've got in the coordinates and the distance into the distance formula. So I'm going to start with this formula here, and what I'm then going to do is I'm going to write a 5 at this side here as the length of the line, and that's going to be equal to the square root of, and I'm going to go for this being the x1, this being y1, this here being x2, and that being y2 there. So let's put the coordinates in. So it's going to be k, take away 9, and that's going to be squared. It's going to be added in the formula, and what I'll go for is minus 8, and I'm going to subtract from that minus 4, and that's going to work out to be a plus that's going to be in there, because minus minus is going to be a plus 4. On this side over here, what I've got is I've got 5, but I'm going to get rid of this square root sign first of all, and what I'm going to do is I'm going to square both sides, okay? So I'm going to square both sides. So on this side here, it's going to be 5 squared. When I square this side, the square root will disappear. What we'll do here is I'm going to multiply this bracket out at the same time. You can use it by FOIL or any other method that you know how to multiply this out. So that's going to be k squared minus 18k, and that's going to be plus 81. From there, what I'm going to do is I'm going to work this part out. So that's going to be plus, and that's going to be minus 8 plus 4 will give me minus 4 squared. Okay. Let's square things out, and then what we'll do is we'll gather them all onto one side. So that will be 25 here. This would be k squared minus 18k. I've got plus 81, and here I've got plus 16. So minus 4 squared will be 16, and I've got a plus sign there. Let's gather everything onto the right hand side. So that should give me k squared minus 18k, and when I gather all the numbers together, that should give me plus 72. Okay. Now what I've got is I've got a trinomial, and what I'll have to do there, when I get a trinomial in this form, I'll factorise it out. So factorising, putting it into 2 brackets, and that looks as though I'm going to have 2 solutions for the value of k. So 2 numbers that multiply together to get k squared will be k and k, and 72 made up of multiplying 2 numbers that when they're gathered give me 18. Well, that's going to give me 12, and it'll give me 6. Okay, they'll multiply together to get that. The signs, I've got a positive sign there, so both of these are positive or both are negative. Looking at that sign there tells me that both of them are going to be negative. From here, what I can say is that k minus 6 is going to be equal to 0. Or what I've got is I've got k minus 12 is going to be equal to 0. So what we have as a solution, k is going to be equal to, I take the 6 over to the other side, 6, or we've got k is going to be equal to 12 coming over to that side, 12. And that's going to be that question complete. If you get any problems with factorising, what you can do is look at one of the other clips that I've got on factorising and see the method that I use to try and make that kind of a simple process to try and complete. Right, what I'd like you to do is to try these questions here, just based on the same method that I've used. Remember, we're looking for 2 solutions, most likely coming out of each of these questions here, and go and have a go at that. Once you've done that, there's questions here from the textbook, the Maths in Action textbook, and go ahead, try the questions that are there to make sure that you look at some of the more complex questions. Some of the questions that we've got are points inside, outside, or on a circle, proving that triangles are isosceles, and using the converse of Pythagoras once you're working with some triangles. So a mixture of questions there that are well worth doing. Freeze the video, try questions 2 and 3. I'll give you the answers in 1 second. Okay, so the answer for this one here, we're going to go for k is going to be equal to, so we're going to have 3, or k is equal to minus 13. So there's 2 solutions for question number 2. And for question number 3, we've got k is going to be equal to 8, or k is equal to minus 10. Right, so they're the solutions for these ones. Okay, so that's just one skill that you've learned. It's the distance formula, similar to Pythagoras Theorem, and sometimes we have to work backwards to find out missing coordinates. Hope this has helped you understand the distance formula.